So here's another power series where we're being asked to find the radius and interval of convergence. So we're still going to apply the ratio test. Remember, whenever we do the ratio test, we always have to include absolute values. And what that does, it kind of eliminates anything that's alternating for us. Also, you want to put an n plus 1 everywhere there's an n. And this one, that can get a little bit tricky. So I'm going to go ahead and rewrite my limit where it's not a complex fraction. And I am going to go ahead and reduce, because remember, if it's in absolute value signs, -1 squared and -1 to the 1, right? Those are both 1 now. So those are going to reduce. I have x. That's going to be 2n. This is 2n plus 2 plus 1, right? So I've got 2n plus 3. And then we are multiplying by 2n plus 1 factorial. And then I have x to the 2n plus 1. And then this is 2n plus 3 factorial. Now, the order of that really does matter, right? You have to distribute, make sure the factorial is on the outside. So that really is going to impact how we work with the algebra of a factorial. So now let's see what reduces. I know a little bit more about factorials now that we're at this point in the year. I'm going to subtract these powers, right? So 2n plus 3 minus 2n plus 1. So I'm left with an x squared on the bottom. And as far as the factorials go, if you need to write these out, you can. You don't have to. That's kind of the beginning of the top, the numerator. And then on the bottom, you'd have 2n plus 3, and then 2n plus 2, and then 2n plus 1, and that would continue to decrease. So just a little bit. Sorry, that kind of fixed that. There we go. So I've got 2n plus 1, and then my 2n's would cancel all the way down. This is all I have left. So I've got 2n plus 2, plus 3, and 2n plus 2. Now remember, this is a limit as n goes to infinity. So this x really doesn't mean much to me. I like to pull that x out to the front. Because it's squared, the absolute values actually don't do anything for me. But I like to leave that absolute value just to make sure. And this is a relatively easy limit. Obviously, the bottom is growing, the top isn't. So you have x squared times 0. So no matter what x is, I'm always going to get 0, which means that any x value would create a series that would converge, no matter what x value I plug in, because 0 is less than 1, right? So our radius is going to be infinity, and our interval of convergence is from -infinity to infinity. I like to write these out in inequality notation, but obviously you could also do interval notation. Either one of those is just fine. Now let's do one more where we're being asked to find the radius and interval of convergence. This one looks a little simpler, but it is a power series. So I'm going to do the limit as n goes to infinity. Remember, n plus 1 over a sub n. We do get some reducing. I get the limit as n goes to infinity of n plus 1 times x minus 3. So the x minus 3 I can move to the front because it's the limit as n goes to infinity. So I've got x minus 3, and this limit, right, is going to be infinite. So x minus 3 times some sort of really large number, right, that's always going to be greater than 1. Right, so that means that this series diverges for any x value that I plug in. But that doesn't mean that I don't have any convergence. We always have convergence at the center. Okay, we'll only converge at x equals 3. So if you plug in a 3 here, you're going to get 0 times infinity. So that 0, I'm going to actually show you based on the Taylor polynomial a little bit more about that. But it will converge at the center. So if we have a radius of 0, but our interval of convergence, we often write, when we only want to list the term, we'll often write it in brackets. You can also just write x equals 3. Now, just to make sure that, why is this only converging at x equals c? Right? Like, how does it converge if this infinity, right? Like, how am I getting that convergence piece? Well, remember that the formula is f of c plus f prime of c times x minus c. Oh, let me do f of x as approximately. There we go. All right, and then plus f double prime of c times x minus c squared over 2 factorial, dot, 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 right? So if I plug in the center, this is going to be a 0 term. This is going to be a 0 term. They're all going to be 0 terms except for this. So when you plug in the center, you do get that value. So you're going to have a value, right, when you plug in the center. So f of x is going to be approximated by the center value every time. Even though all of this stuff goes away when you plug in the c, this term does not. So that's why this works. And that's why we can always include the center for convergence. Okay. Here are just a few notes, right? So these are just some of the factorials that we've already seen quite a bit of, but it's kind of nice to know that this is a reference tool in your notes from here on out.